Hello friends, good morning. In my previous lecture, I had explained plug setting, time multiplier setting, and plug setting multiplier of inverse characteristic relay. Today, I will discuss the characteristic equation of the inverse characteristic relay. These things are necessary to understand before going to the application part of the inverse characteristic relay. Let us start with the characteristic equation. The characteristic equation of inverse time relay is given by this k into time multiplier setting divided by plug setting multiplier to the power n minus 1. Sometimes in place of plug setting multiplier, we take relay current. So equation will be k into time multiplier setting divided by current to the power n minus 1. This is the general characteristic of inverse time relay. Now, if it is inverse definite minimum time relay, that is IDMT relay, K is 0.14 in this equation and N is 0.2. For IDMT relay, K is 0.14 and N is 0.2. If it is very inverse relay, then K is 13.5 and N can be any value from 1 to 2. Normally, we take this as 1. For extremely inverse relay, K is 80 and N is greater than or equal to 2. Normally, we take this as 2. You can see here as degree of inverseness from IDMT to very inverse to extremely inverse is increasing. The value of K as well as N is increasing. N decides basically the degree of inverseness. Now I will take one numerical to explain the effect of K and N on computed time and how this operating time is changing for same time multiplier setting and same plug setting multiplier when we are changing the type of the relay from IDMT to very inverse to extremely inverse. So let us start with the numerical. Numerical is a distribution line is protected by 1 ampere over current relay. CT ratio is 100 by 1. Plug setting is 0.5. Time multiplier setting is 0.2. Compute the operating time of the relay for fault current of 1000 ampere. When first case is it is IDMT relay, second case it is very inverse relay, and third case it is extremely inverse relay. So this is the basic equation. Let us go for the solution. It is the basic equation of the inverse characteristic relay K into time multiplier setting divided by plug setting multiplier to the power n minus 1. K and N will change according to the type of the relay. So in this equation, we require time multiplier setting and plug setting multiplier. Time multiplier setting is given, it is 0.2. So first let us compute plug setting multiplier. In my last lecture, I had explained how to compute plug setting multiplier. It is relay current divided by pickup. So if pickup of the relay we are taking from the secondary side of CT, then relay current should also be taken from the secondary side of the CT. So let us first compute this from the secondary side of CT. So pickup of the relay is plug setting multiplied by rated current. Rated current is given in the numerical, it is 1 ampere. Plug setting is 50% means 0.5. So pickup is 0.5 ampere. Now relay current is 1000 ampere. This is from the primary side of the CT. CT ratio is 100 by 1. So when it is 100 ampere, current is 1 ampere. So when it is 1000 ampere, current on the secondary side will be 10 amperes. So this is how it is computed, 1000 divided by CT ratio. So it is coming 10 amperes. So plug setting multiplier is relay current, that is 10 divided by pickup 0.5. So it is coming plug setting multiplier is 20. Now let us compute this from the primary side of CT. If it is from primary side of the CT, then relay current will be 1000 ampere. Now pickup of the relay from secondary side is 0.5 ampere. So when 0.5 ampere is computed on the primary side of the CT. For 1 ampere it is 100 ampere. So when it is 0.5 it will be 50 amperes. So 1000 is relay current divided by pickup from the primary side, that is 50. So again it will come 1000 by 50, that is equal to 20. So plug setting multiplier is 20. Now let us come. So equation will become K into 0.2 because time multiplier setting is 0.2. Plug setting multiplier is 20. So 20 to the power n minus 1. For IDMT relay, K is 0.14 and n is 0.02. Substitute the values. So we get time is 0.4534 seconds. For very inverse relay, K is 13.5 and n is 1. So 13.5 into 0.2, that is time multiplier setting, divided by 20 to the power 1 minus 1. So operating time is coming 0.1421 seconds. For extremely inverse relay, K is 80 and n is 2. So substitute these values. So 80 into 0.2, 20, that is plug setting multiplier to the power 2 minus 1, it is coming 0.4 second. So now you can compare the operating time for different relay characteristics. For IDMT, it is 0.45 seconds. For very inverse, it has reduced to 0.14 seconds. And for extremely inverse, it has further reduced to 0.04 seconds. So you can see here how the degree of inverseness affects the operating time. As degree of inverseness increases, the operating time reduces. So that is how the degree of inverseness affects the operating time. In my next class, I will explain how to compute the plug setting and time multiplier setting of inverse characteristic relay when it is used for protection of distribution line, that is low voltage line. If you feel this lecture useful to you, then please like it, subscribe to my channel, ask your friends, colleagues, classmates to subscribe to my channel for upcoming lectures on high voltage engineering and power system protection. If you want to make effective and efficient use of time, then read my book on time management. The link for the book is given in the description box. I have launched one course on UDEMY, that is boost your learning and become top achiever. This course is useful for the students and particularly for the students who are appearing for competitive and entrance exams. The link for the course is also given in the description box. Thank you.